Boa tarde a todos. Essa é uma apresentação formal da apresentação do trabalho do Jan-Rik, intitulado Myoelectrical Upper Limb Prosthesis Project. E a gente tem um ritual para cumprir. Então, as perguntas que deverão ser feitas só poderão ser feitas no final. Okay, it's a formal presentation, right? And in the final of the presentation of Jan-Rik, we give the word to André and Roger, talking about your critiques and suggestions. And after these comments, we open to questions for you, right? Between this presentation, we don't ask Jan-Rik about any question. Only after this presentation, right? No problem. Okay. Thank you, Roger. Thank you, Andrea. Thank you, everybody. And I want the word to Jan-Rik.
Okay. Welcome everybody to my presentation. It's about my final project, about a myoelectric upper limb prosthesis. I'd like to tell you today something about what I did the last half a year here in Brazil. First, an introduction. This morning when I woke up, I opened a bottle of water and drank of it, and it was very easy to do with two hands. I thought of it, and it's just like people who do not have an arm or have been amputated. They have a lot of struggles with this, of course, and I'm here to find a solution for that problem. Really cheap. But today I'm going to talk to you about a little research I did, about designing, about a manual I made, prototyping, and the conclusion about it. Very briefly, I wanted to tell you about, you can ask questions anytime, but you just said that it's not necessary. Can everybody understand me, or am I talking too fast? It's okay? Okay, let's start. The goal of this project is about the development, if it is possible, to develop a prosthesis, myoelectric controlled, for less than €300, which means the myoelectric is actually muscle signal powered. But I will tell you about this a little bit more in the next slides. The prosthesis is meant to the middle third forearm amputations. So it's an area, it's a stated area. Other dimensions, other amputations are not encountered in this project. Research. Most research I did was about electrical components. These are an Arduino Uno, muscle sensor, and commonly used batteries. And when I found some information about these components, I tried to make it most compact, and that's what I'm going to tell you now. First, I wanted to know how I needed to install the electrical components before I went designing, and this is why, to understand how much space I need to make the prosthesis. According to the other project of my Dutch friend, Stefan, the servo motor, as can be seen in this picture here, this is a servo, is in need of 4.8 volts, 2300 milliamperes per hour, and I needed to find a battery pack for that. I can show another picture later on. This is how it needs to be installed. The red and yellow and black lines you can see on the arm is about the signals to gather the electrodes. You need to place electrodes on the skin of the patient. By contracting the muscle, you get a signal. The signal will be captured by the sensor, that's the red box. The red box gives a signal to Arduino. The Arduino, if the signal is above or below a certain value, it will give or will not give a signal to the servo motor, which controls the movement of fingers. The Arduino is powered by the two 9-volt batteries, as well as the sensor. And that's about how I needed to install all of the components. Then I found the sizes of all the components, and then and the weights as well. These batteries, I need 2 of the 9 volts. It's about 100 grams, so it became already a heavy Prosthesis. Then the battery pack itself was 100 grams as well. And Arduino is a kind of big microcontroller, and the sensor, no, it's not a problem at all. So I went shuffling and make it most compact. I came up with this. In order to control everything and to be sure that there's still space for wiring, I placed it like this. The total space needed 105 millimeters in the length, 45 width, and 65 millimeters high. And therefore already it is a big Prosthesis, because there's still not a housing on them. The sensor is placed on top, and this is because of the ability to power. No, it's saying wrong. To guide the electrodes, it is placed with a cable, and the cable needs to be inserted in the sensor. To do this easily, I thought it would be nice to do this on top, and that's why I placed it there. Then I went designing, since I found the space I needed. There's stated that it should be anthropomorphic. That means that it should be looking like a human. That all the components fit into the arm. And I made another part which is connected, which connects the arm into the residual limb. And this part is called socket. So to get the shape, I first started designing, but that took a long time. And later on we could use a 3D scanner, which is here in UCL. We started scanning, we got a model as can be seen on the right picture. This model I cut off the hand, because I only need to make the arm of the Prosthesis. Yeah, something like that. This model was obtained in SolidWorks, is a program I'm working with to design. And by redrawing this model, I got all the dimensions and the relationships between the dimensions of a human arm. So I could work with that. Then I tried to fit in. I made the arm 105 millimeters, 45 wide, 65 height, like it was needed. And as you can see, it does not fit in. Another solution I had to find, and therefore I started designing, like there's a box around the electrical components, and how can I make the arm more by changing the relationships between the dimensions. I gathered another design. So I made a final design. All the components could fit in. Now, this is my final design. Should I talk more about this or not? Well, all the components can fit in right now. It's obtainable to replace the batteries by the hood. I can show you later on. And that's my final design. And now I needed to find a way to connect this arm until the residual limb, the part socket. So I made the socket, and I made it in a smart design, very simple socket. And this is because of nobody has the same residual limb. So it is not possible to make just one socket. It doesn't fit. So I made a smart design, which I would like to show you if that is okay. And maybe you can understand a little bit more what I mean with smart design. So, when a person downloads all of the parts, This is not going to work well, I see on my screen. I will try. The scope. Male. When a person downloads all the parts, it is easy to see to open the parts. A patient can change the dimensions of the socket. You need to do this for all parts of the socket, which is in the folder I just opened. By simply clicking here on the equation box and managing equations, you can fill in the diameter of the residual limb. This is a place where it's cut off. So let's take a value like 60. If all is okay, it changes. And now this is round 60. So, and here's another part. Can you see it well? A little, right? Do this the same, equation box, and fill in this dimension, 60. And at the end, where the elbow is at, there's a diameter as well. If you measure it well, you can put in any value, like 80, not 800. And the length of 100 is okay for now. And the socket is changed. And if you go to the assembly of the prosthesis, where is it? I'm sorry. Rebuild, and now you got a socket which is made by your own dimensions. You can save this again as STL files, and then it is possible to have your own socket. Why are there 3 lips and why is it a little small? It's because of the placement of the electrodes. You need to encounter that as well. And this placement, I placed 3 in 120 degrees round, and it is because of nobody has the same different muscle area as well. So you need to find, first you need to find where the electrodes can be placed, and then where there's space for the lips. It can all be changed very easily. I need to open the PowerPoint again. No. Where were we? Here. So that was the part socket. After the design, the final design, I made a manual. The manual describes all parts, how you should place them on the 3D printed bed, how long it takes to manufacture all the parts, and how much filament you need in meters. These calculations are based on 3 millimeters thickness of the filament and 0.3 millimeters per layer that you're printing. This is just a value to give an example. At the right you can see all the parts that I printed, because it was time for the prototype. After I gathered all the materials and I printed all the parts, I could assemble the prosthesis. I used a printer here at UCL, and the prototyping went very well. I could test it on a patient's body, on the residual limb of a patient. This man had an amputation not at the middle third, but at the beginning of the arm. So it was not getting really anthropomorphic as well. But I could test if the socket worked, and I placed it on his residual limb with the sleeve, and attached it with Velcro, really simple, everywhere available. And I could not take it off of his body by pulling it, so I think it has proven that the socket fits very well. The arm could be attached on his body, and it appeared that he found it really heavy and really big, but that was quite expectable because he has an amputation at the wrong level. So that was my prototyping session, I believe that was. And now some conclusions about it. I went one too far, I believe. So in the beginning there was a question like, can you make this Prosthesis for less than 300 euros? All the electrical components cost around 100 euros. Whereas I did not encounter the calculations on the hand, because that's part of Stefan. For material, ABS material is like 17 euros. When you do not encounter the manufacturing hours, that is the total around 120 euros, where I thought it's like 50 euros for the hand in total. So a total of 170 euros, which is less than 300 euros, which was the maximum. So that fitted, that it went okay. Another conclusion is that because of printing it, made it by to fit it on the patient we were working on. It was not normal. It did not look up. It did not appear well. So I made another arm without any electrical components. These components are placed on the back right now, and therefore it is possible to make a prosthesis exactly as the dimensions of the opposite arm of the patient. It's the same smart design as I showed you with the socket, but I can show you that as well. I would like you to show you, and that's going to happen right now. So when you go to, maybe that's nice to tell as well, it should be an open source base, so it should be obtainable on the internet. I made a document already, which should be ready for placing on the internet when all is finished. So you get a choice, arm left, arm right. The manual is here. You go to arm right. And now without electronics, there's a special manual without electronics, how you should do things differently. Go to the SolidWorks arm. And all these parts you need to open. And I made this really easy. There's only, in here, there's only one loft, which is there for the wiring of the servo motor. That will always be the necessary. And in here, the only thing you need to do is open the manage equations box again and insert the length of the arm that is missing. So let's say 50. And the width of the wrist. That's, I do not know how to show you this right now, but there's this dimension. So let's put there a value of 40. And if all is well, we now have a changed model. It's really, wow, really small. Too small, I believe, because it's not going well. And I don't know why. The scope. Do this the same for here. It's going to take a while. Did I do it like this or the other way around? Don't know anymore. Well. need to work with two hands. Go fast. Click rebuild. Now, as you can see, I need to change some more. Why is this not going well?
I think one of them you use 60, the other 40.
Yeah.
Oh, that's why. Okay. Sorry.
That one.
This one. That's better. Open this one. This is the ring that flows over the arm to connect the top and the bottom of the arm. As well. I don't know why this is not going well. I really don't. Well, this could have been really well, but didn't work. There's a little problem. I don't know what it is. Yeah, Morphe's law. When it needs to work, it doesn't work. Too small, probably. I think it is because now I know why. I made this 35 millimeters round. It is a stated value. When you put in a value which results in less than 35 millimeters, like I did right now, it does not work. I'm sorry for that. I just go really fast. So this was the other conclusion. So it is possible to make a myoelectric prosthesis for everybody, for every patient. It is possible. Just due to the fact that you can change the socket and you can change the arm if you think this one is too big or too heavy. So therefore I think the project worked well. I'm really glad with the results. So that was about it what I wanted to tell you. Well, I just can not say anything else that everything is different. Nothing is done the same. If you make an appointment here at 9 o'clock, for example, it will be 9 o'clock in the Netherlands, actually 5 minutes before 9. When here it's just like 10 minutes later, 15 minutes later. But these things happen, and I in the beginning I had a real big problem with that, to get used to that. Why would you otherwise make an appointment? But later on I learned how you live, what you do, how it works. I still do not agree, but I can understand right now. But what Uchieli did to me, I don't know. It's just like, go on, work, give me results. I will not stop you. I will help you with everything you need. And that's another thing in what I think in the Hanze Hogeschool, my college, is like, if you want something, it's possible, but you need to hand in a lot of forms and things, and it takes a long time before you actually can do something. In the Netherlands, yeah. There is one, two maybe, two. But I could have worked with that as well there, but well, Thomas as well, I can give him a gratitude for helping us as well a lot of times. So that's another, everybody wants to help you here. In the Netherlands, they will be a little bit more focused on themselves. No, I need to do this today, so I can help you, but maybe when I have time to help you. And here is it, hey, can you help me? Oh, claro, I will help you, like right now. So these are the differences. I think it's really nice to have met these people, these things. Yeah, everything is else. Everything is different. And the weather, of course. So yeah, that's I think that's, but yeah, I think that's it. Yeah. Yeah, muito bom. Really good experience. I will, yeah.